Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're back with a 7th grade topic, finding the area of complex shapes. In order to not waste any of your time, I'll be putting all the time codes to my video in the description box below. So feel free at any point in this video to skip ahead to the sections that interest you the most. As always, if you have any questions, feel free to put them in the comment box below. I'd love to be able to help you as much as I can. If you have any questions about your own homework let's see on this channel, remember to visit me on Facebook at Tutor Me Sempai and tell me about it there. When you find this video helpful, remember to leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Without further ado, let's talk a little bit more about finding the area of these complex shapes. Before we jump into finding the area of complex shapes, it is important that you know what the area formulas are for your regular shapes. So let's write a few of them down here. So here are some basic area formulas that would be helpful if you can remember them, but if you can't, just try to have a cheat sheet that you can use for your homework so you can reference them whenever you need them. So you have your area of a circle, your square, your rectangle, your area of your trapezoid, your triangle, and here's an area of a parallelogram. So these are some common areas that will be useful when we're going to find the area of these complex shapes. Now that we've talked about the area formulas that are going to be used when finding the area of these complex shapes, let's talk about what steps are going to be necessary to find the area of these complex shapes. There are not going to be that many steps for this, so don't worry. The first step would be to identify all possible shapes in your complex shape. You'll see what I mean by this step in our example for today. However, you should know you have to figure out what your shapes are first. Sometimes you're going to have shapes you won't use, and other times you'll use them all, but you need to know what your possible shapes are. Your second step, choose the best shapes. Now this is going to be a personal preference, but you want to choose the best shapes that are going to help you find the total area of your complex shape. Your third step is find the area of all your chosen shapes. So if you chose 3 shapes out of your possible shapes, you want to find the area of each of those 3 shapes. That's going to be very important. And the last step, you want to add and or subtract the areas you found. There will be times where you add up all your areas for all the shapes, but there will also be times where you're going to subtract areas. So you're going to have to see what's necessary for the question at hand, but your last step is add and or subtract the areas that you found. So here are 4 simple steps that are going to help you when you're trying to find the area of these complex shapes. So let's jump into our first question for today. So this is our first question for today. We have this complex shape that we're going to try to find the area of. I've drawn it here so that we can draw and follow these steps when we're trying to identify all of our shapes and then find the areas for those. Notice I have all the steps that we just talked about at the top right here, and I've abbreviated them so they can fit. The first one being identify all your shapes, choose your best one is the second, find the area of each of those, and then your last one is add or subtract the areas that you just found. So we're going to use all 4 of these steps to find the area of this irregular shape. So let's start with our first step, identify all your shapes. And remember, this is going to be up to you. This is a personal preference. Notice if I were to connect my lines as such, I have one triangle here, a second triangle. This would be some type of parallelogram. We don't know if it's a square or a rectangle. Here's another parallelogram. Not sure if it's a square or rectangle. So we identify these 4 shapes. Are those all the shapes that you have here? No. You have a bunch more you can choose from. For example, you could have this, and this would be one shape. You could have this, and that triangle would be another shape. You could have the entire box, rectangle or square here, and that would be another shape. You have a lot of different shapes here. So identifying all your shapes doesn't mean you have to use each and every one of these. Just understanding that this has a lot of shapes to choose from. Don't want you to think that you have to do one or the other if there are a lot of different choices here. Choose your best one is the second step. After you have identified which shapes you can use, choose which one do you think is going to give you the least amount of work. I'm lazy, so I don't really like doing much more work than I have to, so I'm trying to use the best one to give me my answer as quick as possible. Now you might be asking, Courtney, how can this 6 be a shape that we're considering? This 6 is outside of our shape here, and this 7 is more than we have for our regular shape. That's where this add or subtract comes in, and you'll see about that later. So I'm going to use 6 and 7 as my shapes for my second step. Those are going to be my best ones because those are going to be a little easy for me to work with. Now we have to find the area of these two shapes. So this area of 7, you notice that we have a square. And remember, our square, the area of a square, is going to be the side squared, right? So the area of a square is going to be the side squared. Because all the sides are the same, you're doing side times side. So what's the side for this square? Well, this is going to be 15, right? So we have 15 squared. And what's 15 squared? Well, that's going to be 225. All right, so we've done the area for the square. How about this triangle? 6. Well, the area of a triangle is going to be what? Well, that's going to be 1/2 base times the height. But what's the base and what's the height for this? Well, let's look back at our numbers here. Our original numbers, actually, let's clean this up a little bit so we don't get confused with all the extra numbers I drew here. So our original shape looked something like this. And we said we want to look at this triangle here. So I close this triangle. We want to look at this triangle. But we need a base and a height. Well, the height is going to be this here, right? And our base is going to be this here. Well, what's the base? Well, the base is going to be actually the side of this square here, right? This square is going to be equal on all 4 sides. This base is one of those sides. So this square actually tells us what our base of our triangle is going to be. So the base of our triangle is going to be 15. Now we need to find the height. What is our height? So looking at this, we see we have 3 numbers here, 15, 15, and 8. Our height is going to be something here. How do we find our height from the numbers that we have here? Well, notice that this distance is going to be the difference between the total side and this smaller side, right? That difference is exactly this height. So what's 15 minus 8? Well, that's 7. So this distance here, this height, is 7. So our height for our triangle is 7. So now we have our base and our height. Let's multiply these and figure out what our number is. Well, this is going to be 52.5. So we found the area of both of our shapes. Now we move on to our final step, where we're going to add and or subtract our areas we just found. So since there's only 2 areas here, we're either going to add them or subtract them. So which one do we do? Well, notice these 2 shapes actually have more space in them than our original shape intended. This right here is more than our original space. So if we start here and add more to it, we're going to have more area than our original shape had. So we can't add these 2. We're going to have to subtract them. Because if you notice, this square, if we subtract that triangle, we have our shape left. So we're going to find the total area of the square, which we did, subtract our smaller triangle, and we're going to get our total area of our complex shape. So we're going to do area of the square minus the area of the triangle. And this is going to be the area of our complex shape. So what's the area of the square again? This is 225. So we're going to subtract 52.5 from 225. And what does that give you? Well, that gives you 172.5. And that is our area of our complex shape. We identified all the shapes. We chose the best ones. I chose 7 and 6 from the options that we drew because it was just easy for me to find the area with those without having to do a bunch more work. Then we found those areas, and then for this example we had to subtract because we had too much area to work with. So we couldn't add them. We had to get down, boil it down, shave it down to what we originally had. So we subtracted the areas. And now that we subtracted the areas, we know our answer for this question is 172.5, and it's going to be meters squared because that's the units that we're working with. Area is always squared, so it's going to be meters squared. So let's look at one more quick example. Here we have this complex shape. So we need to identify all of our shapes as our first step. And this one's going to be a little bit easy because we have a rectangle here, right? So this is our first shape. And we have a half circle as our second shape. So we can move on to choosing the best ones, which is just going to be what we have here. There's not much else that you have to work with. So the second step kind of gets boiled into the first step. So now that we know we're going to be using 1 and 2, let's find the area of those. So what's the area of a rectangle? That's going to be length times width. And what's the area of a circle? That's going to be pi r squared. So we have the area of the rectangle formula and an area of a circle. What's the length and the width for our rectangle? Well, that's going to be 5 times 12, right? 5 times 12 is going to be the length and the width of our rectangle. And what's 5 times 12? Well, that's going to be 60. How about our area of a circle? Well, before we do this, let's not move forward without realizing this is not a whole circle. So we're actually going to use half of the area of a circle because this is the area of a semicircle. So instead of finding the area of a circle, we want the area of a semicircle, which is 1/2 the area of a circle, which is 1/2 pi r squared. So don't fall into this trap here. This is not the area of a circle, this is half the circle. So what's our r? Well, we know our diameter because this goes all the way across here through the center, one point on the circle to the other point of the circle. So we know our diameter is going to be the same length as this side of our rectangle. So if our diameter is 5, what is our radius? Well, our radius is going to be half of 5. So 5 over 2. So we're going to plug that in and we get 1/2 pi 5 over 2 squared. And this is going to be equivalent roughly 9.82 if you were to put that in a calculator. So the area of our complex shape, I'm going to say CS so you don't confuse it with circle. Our complex shape is going to be the area of our rectangle plus, this case is going to be a plus because we're not going to subtract. If we subtract anything, we're not going to get the entire area. So we need to add these two. So in this example, we're going to add them. Plus the area of our semicircle. And what's the area of our rectangle? 60. And what's the approximate area of our semicircle? That's going to be 9.82. So when we add those together, we get 69.82. That is going to be our answer. But don't forget the units. This is in inches, so it's inches squared. Those are going to be the units for our complex shape. And our area is going to be an approximate 69.82 inches squared. Well, I hope you're able to follow into these examples. And I hope you found the time codes useful. Remember, if you have any questions whatsoever about what you saw here today, or even your own homework, feel free to put them in the comment box below, or visit me on Facebook at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Sempai.